All right. Hi, everybody. I'm Les Warren. I am a PhD student here at Purdue in the Department of Forestry and Natural Resources. And I'm just going to give you a brief snapshot of a large part of my dissertation I've been working on, quantifying the importance of alternate nursery habitats to alewife recruitment in Lake Michigan. Yep, next slide. So before I get into my study objectives, just a little bit of background for you that don't know. Alewife are small prey fish in Lake Michigan. They're really important primary prey for a lot of salmon species. And in recent years, the alewife population has been in decline. So fisheries managers are interested in learning more about how they are successful, how they can be more successful in recruiting in Lake Michigan. So the study objectives, over the last 2 summers, I have sampled 4 different locations in Lake Michigan, shown on the map there, including 4 river mouths and 4 nearshore environments of Lake Michigan. And we wanted to first characterize the nursery environments. So this included taking a lot of water temperatures, dissolved oxygen, Secchi discs, to kind of differentiate these habitats from each other. Second, estimate the habitat-specific performance. This includes things like hatch dates, growth rates, and survival of these larval alewife in these different habitats. And third, compare these results to a similar study performed 20 years prior. So the last 2 years, a large part of this has been a lot of sampling to be able to obtain these larval alewife from these different habitats. So some really snapshot results, since we don't have a lot of time, but just looking at these different nursery habitats. So I guess I should have specified, when I say different habitats, we're looking at the near shore of Lake Michigan, but then as a tributary habitat, that would include habitats like drowned river mouth lakes or river mouths like I sampled St. Joe's and Trail Creek in Michigan City. But just very generally looking at these tributaries versus the near shore, we observed that tributaries in general had warmer water temperatures. Looking at the plots there, you can see that's just an example of Muskegon Lake. That Muskegon Lake was warmer throughout the entire growing season for these larval alewife than of Lake Michigan. But they also had decreased water clarity, so higher turbidity that may be aid in predation risk, and also greater zooplankton biomass in these tributary environments. Just very briefly with the habitat-specific performance, the tributaries we observed had earlier hatch rates, higher growth rates, and also higher densities of larval alewife compared to the near shore of Lake Michigan. You go. Sorry, no, you're good. Just not to throw a lot of numbers at you, but the biggest takeaway here is that in 2001, it was observed that the growth rates between Muskegon Lake and Drowned River and of course the near shore Lake Michigan were pretty similar. But in 2021, we're seeing that Muskegon Lake stayed pretty similar to 20 years prior, but we're seeing decreased growth rates in Lake Michigan. And just some next steps. I have a ton of laboratory processing to continue up. So like I said, I did this for 2 summers. So some of the data I showed you was just the first year. So this summer, I hope to extract otoliths and age individual larvae from the second summer, along with looking at some diets. But also a ton of data analysis and writing, and another plug like Brooke. Next week, if any of you are up at IAGLR in Toronto, I'll be giving a more in-depth talk on this research. So thank you.